Good evening, and thank you so much for being here. Today, I'm Laksh, by the way, and this is Vidhu. So I actually ended my last year's RSA talk at the DevSecOps sessions with this quote. Security is actually proto-science. AppSec, more so. We don't have all the answers. If we did, we all wouldn't be here. And if anyone pretends that they have all the answers, just run away from them. What I can tell is that let's all take a very scientific approach to solving security and try different things, see what works, keep it, and discard what doesn't. All right, great. So with that said, I'm going to dive into a quick introduction and set some context on what this presentation is all about. This is a case study about the deployment of ScoreBot, which stands for Secure Code Review Bot at PayPal. I did not come up with the name. All the credit should go to Vidhu. Pretty creative there. It's not a silver bullet. We're not saying that it's going to solve all your security problems, but we're just sharing what worked for us. And it's completely vendor neutral. In case I mention any vendor names, it's not an endorsement. It's more of an habit, and definitely not a sales pitch for that. And it's purely descriptive. I'm going to explain, and we're going to showcase what we did, what worked, what were the results, what were some of the challenges, and stuff like that. And by no way it's prescriptive, because if you try to do this, a lot of it depends on your infrastructure, more importantly, culture of the organization. So your mileage may vary. All right. So quick agenda. I'm gonna start out with a quick overview of secure product lifecycle at PayPal, and then we're going to talk about our landscape and kind of give you a overview of our problem statement. Then we're going to dive into the design of what ScoreBot is, and then the real meat of the presentation, which is a live demo. We're going to attempt a live demo. A lot of variables at play, but we're going to try it. And then show what were the benefits, what was the ROI on this. All right, so secure product lifecycle at PayPal's objective is to reduce the number of vulnerabilities in our products over time, not overnight, over time, by building repeatable, sustainable, proactive security practices that are embedded seamlessly within our product lifecycle. So with that objective, we obviously do a bunch of different things. So it's a combination of best of the breed security tooling, processes, training, both traditional and non-traditional, and a combination of all of that actually makes up our secure product lifecycle program at PayPal. All right, so let's look at our landscape. So for this presentation, we're just looking at our core product development organization. Obviously, as you may know, we have a lot of acquisitions and other brands, so we're going to leave them out of scope for now. Just looking at our core product development organization, which is basically PayPal.com and all of the mobile apps and the infrastructure that goes around that. We have over 4,000 developers, a bunch of different custom application frameworks on top of which our developers build our applications, diverse programming languages. We still run a CGI bin C++ web app, and we also run Node.js at the same time. And what are the problems we're trying to solve here, right? One of the key challenges is when a code review happens, it's more around coding styles, functionalities, things of that nature. But what about security? We definitely want to bring security to the table when somebody submits a pull request and the submitter and the reviewer get together and look at the code and review it. And the other big thing we're trying to solve here is there are generic technical security flaws. Think of cross-site scripting, SQL injection, CSRF, things of that nature. We're not talking about that. We're talking about PayPal-specific vulnerabilities. What do I mean by that? We have, as I mentioned earlier, custom frameworks, libraries, APIs, things like that. And there's a possibility that there could be vulnerabilities in them. Some of them could be deprecated, and we want our developers to use the latest and greatest. And so PayPal-specific issues, things, issues in our logging platforms and APIs, crypto platforms and APIs, stuff like that. And also, things that are not technically vulnerabilities, but just deviations from our internal security standards. So we want to catch them and flag them as well. And obviously, everybody knows that we got to shift left and provide feedback early. And IDE plugins or spell checkers, as some would like to talk about, they are a great idea. It works for a lot of companies. But for us, it was just, we tried, and it's incredibly complex to maintain and update at scale. I have diverse programming languages. I have diverse set of IDEs. We actually have developers who use VI and Emacs. Vidhu is one of them. And ranging from that to WebStorm to Eclipse and so on. So when you have multiple different IDEs, multiple versions of each IDEs, and then you have plugins and plugin compatibility issues, and it just gets messy over time. So if you want a consistent result across the board, it just wasn't working out for us. So we wanted a solution wherein we can shift left as much as we can and provide early feedback to our developers. And the other thing we were trying to solve for is when we know about a vulnerability, from the point of identification and the point at which we have a rule in our CI/CD pipeline that actually starts flagging that for all new development, we want to compress that timeline. When we try to do that with static analysis tools, you got to write custom rules. That's the only way to do it. And you want to do the custom rules, it takes time. You got to figure out how to do it, and then you test it, and there will be false positives. You go back and tweak it, and by the time you end up scaling it across the board, it's too long. It's weeks, if not days. And so we want to get to a point where it's actually in a matter of minutes or hours. We want to be able to identify something and then get something into the CI/CD pipeline as soon as possible so that we can start flagging new issues going forward. And so static analysis tools were pretty heavy, and then maintaining and customizing and keeping them up to date across version upgrades was just too messy. So that's the landscape, that's the problem statement. That's what we're solving for here. All right, so with this context set, what should be our guiding principles? How should we approach this problem, right? The movie, any fans of The Matrix here? I'm one. All right, quite a few fans. The movie may be about 20 years old, but one line that really stuck with me is never send a human to do a machine's job. Yeah, Agent Smith is one of my favorite characters. And so here are our guiding principles. Number one, it's got to be developer friendly. What do I mean by that? Like, developers should not have to learn a new tool, install something, configure something, remember to use it. That's just a non-starter. You gotta put your bots to work, and you gotta put your bots to work in the right way. And more importantly, we have to be empathetic to developers. Our entire engineering org is actually a bunch of developers and who are now security engineers. And so we're really, really empathetic to the developer way of life. And the next thing is we want to solve for scale. Obviously, as I said earlier, we actually do hundreds of deployments to our production site every day. And we have hundreds of components and across diverse programming languages and application frameworks. So we gotta solve for scale. So that's very evident. And at the same time, performance is important too. We want to be able to get the response back to our developers, provide early feedback in a matter of seconds and not a matter of minutes or hours. That's too slow. So we have to be absolutely performant. Then comes behavioral science. My personal aha moment about behavioral science was if I remember correctly, it's back in 2011. So what we did was we actually built a small online training module for our developers, and we sent that to a bunch of product teams. And the click-through rate for that was abysmal. And we were scratching our heads going, why aren't developers clicking there? Why aren't they using that? And then we made just one change in the email campaign, just one change. We added how long was the online training module. It was like 4 minutes and 32 seconds or something like that. And we just added that, and we sent out another set of emails to another product group. And the click-through rate was pretty high. It was like, what's going on here? So when the developers saw the email, they did not know how long was the training module. Maybe it was 30 minutes, maybe it was an hour. They were not ready to commit to it. But it was like 4 minutes, I can commit to that. And so many people clicked through, they actually took that online training course or module. So that was eye-opening. So developers, they are the ones that are writing the code, they're building the products, and in the process, they are the ones that are introducing the vulnerabilities. So if we want to change their behavior, how do we nudge them? How do we remind them at the right time if they're doing something wrong and about to shoot themselves in the foot? So behavioral science was a very important piece for me. And to make that happen, we wanted to bring experimentation as a core feature of Scorebot. What do I mean by experimentation is in the traditional sense, being able to do A/B testing. So if you find a vulnerability, one set of emails and notifications would have a different verbiage, another set of have different verbiage, and then we can compare and see what worked and discard what doesn't work and pick the ones that work. Maybe a set of things that we show for a product team that has native speakers of English who are located here in the Bay Area versus a set of developers who are in China whose English is actually not their native language, not their first language. And so is there a difference? Maybe we don't know. Let's try it out. So this provided us opportunities to run different campaigns and see different results, and we stuck with what works, and we could discard what doesn't work. All right, with that said, I'm going to turn it over to Vidhu. Vidhu's going to provide a high-level overview of the design and talk and actually attempt to do a live demo. All right, over to you, Vidhu.
Check. Can you guys hear me? All right. Thank you, Laksh. Good evening, everybody. All right. So what you're seeing here on the screen is the representation of the high-level design of Scorebot. And as part of PayPal CI/CD pipeline integration, when a developer creates a pull request to obviously merge his local code to the parent repository, Scorebot will receive the new code via an asynchronous hook, and that'll be used as a payload that'll be scanned for PayPal-specific vulnerabilities. Now, we record a lot of metrics associated with the PR, all of the metadata that we will use it later. And if an insecure code is identified by Scorebot in that PR, Scorebot will comment in the PR containing information like what vulnerability is detected, where is it present in the code, because the PR might contain a lot of files, so we specifically tell where that vulnerability is. And we also summarize what is the security issue in the context of the code, and most importantly, how to fix it. Now, there will be also document references with more details on the findings and step-by-step instructions on how to fix it. And my developers love it. Of all the things that we give it to them, they like the step-by-step instructions. And in addition to the PR comment, an email notification with all of this information will be sent out to the developer as well. Now, all of these tasks will be done in near real time from the moment the PR is initiated. And that's the performance guidance that we kind of take very seriously. And there is nothing the developer has to remember to invoke or manually integrate everything from an application perspective to trigger Scorebot. All right, enforcement with empathy. This is one of my favorite lines when I want to talk about the enforcement topic. If you can buy it, you generally don't have to. So I've been a developer myself for a long time before transitioning to a security engineer, as Laksh mentioned. As a matter of fact, a vast majority of our PayPal AppSec engineering organization is folks like that. So when it comes to enforcement, we are absolutely empathetic to our developers, and always try to balance both security and developer experience. Well, almost always. All right, so this is the representation of the enforcement and waiver flow. And as you can see, when the pull request with the